Very good afternoon. I hope you all had a good day, a good keynote sessions, and then a couple of great sessions. Next one, we have Arnie Durdevis and David Templeman. They'll be presenting here, Map Your Lakehouse content. The session is going to be 30 minutes, and then 10 minutes for the questions. But yeah, feel free to, send any questions, and then we'll try to answer those. Thank you. Enjoy, everyone. Over to you.
Thank you very much. So welcome to this talk. My name is Arnie Durdevis. I'm here with David Templeman. We're going to talk about DiscoverX, so a tool to map and scan your lakehouse. So let's dive into the content. So what's in my lakehouse? So this is a question that you probably wonder several times while managing your lakehouse. And there are a lot of questions that come to your mind when you think about, okay, given a lakehouse, what do I have in there? So one of the things that you might be wondering is how many columns that contain email addresses do I have? If I have 700 or 1,000 tables, or how many contain an SSN number, so social security number. So these are very common questions, but maybe there are even more specific questions. So given that I'm looking for IP addresses, so do I have any record that has Ernie at Databricks.com somewhere in my lakehouse? Or do I have this social security number anywhere in my content? So these are very common questions, and what we're going to try to do is explain how to solve these questions over structured data that spans across hundreds of thousands or thousands of tables. So before we begin, let's analyze why this is not easy. Why is it difficult? So if we take a delta table, it's divided in content and metadata. So the content is actually what you have in your data, the actual rows. The metadata is everything that describes it. So the column names, what is the data type, and so on. So you might have metadata that describes it, but this is not, you don't have only one table. You have hundreds or even thousands of tables with their own metadata. So every table has its own schema. So if you're looking for email addresses, you might have to write 30 different queries for 30 different tables because they have different schema. So this is one of the problems. Luckily, we have Unity Catalog. So Unity Catalog would tie all of this together and give you access to the metadata. So you can search in your metadata, and you can basically have an overlook of everything that you have in your lakehouse. But the metadata that you have might not represent 100% what you have in your content. So as you heard this morning at the keynote, we have a lot of efforts going on in order to make this data more meaningful. So understand what is the semantic type of the content and have this information up in the Unity catalog so that we can have better understanding of your lakehouse and enable all the AI technology that will help you understand what is in the content and automatically drive this content. So DiscoverX is one of the efforts behind this to try to give more meaning to Unity catalog. So how can DiscoverX help? So first of all, it runs a scan of your data, so you can scan your data and classify what type of data is in one of the columns. And this will provide content discovery. So you will understand how many rows you have that match a specific type. But this also enables cross-table queries. So this is the magic that once you define that you have email addresses in these 30 columns or 100 columns, then you can run a single query and you can ask, is this email anywhere in here? So DiscoverX will span this query across all of the tables and find the answer to your questions. And this enables GDPR requests. So for instance, right to be forgotten. If you need to delete a user from all of the tables, you can run a single query and will delete it from all of the tables at once. And same for data retrieval. So if you have the GDPR access, you can GDPR access of data request, you can do that. And same for cybersecurity use case. We're going to see in a bit. So how does DiscoverX work? Let's take a look. So first of all, it scans the data. What is it looking for? So given the content, we search for email address, for IPv4, v6, MAC addresses, so cybersecurity, data type, phone numbers, social security numbers, credit card numbers, zip code, you name it. There are 16 different data types, but it will expand soon. But basically anything that can be identified by a regular expression, you can provide it, and you can scan for this regular expression in the content. So how does the scan work? We take a sample of the data, by default 10,000 rows, but you can also take the full content or a smaller part. And for each string column that we encounter, we count how many times the regular expression matches the specific row. And that gives us a percentage of rows for each column that contain email addresses, IP, and so on. So for all the types that we have, and any custom provided data type that you might provide. So this is an example. So once you have DiscoverX pip installed into your notebook, you can do dx.scan, and given some table names, and you can use the asterisk like that. Okay, as a wildcard, and that will basically scan all of the databases and all of the tables within the catalog sample data DiscoverX. So it will select one catalog, and all of the schemas in there is only one, 23 tables, and the 16 rules that we have with a sample size of 1,000, and it will start the scanning. So the scanning will go in parallel. Usually it takes a few seconds per table. And you would get a result summary with what has been found. So for instance, one credit card number, 5 emails, IPv4, and so on. But it will also give you the details of how many rows were matched. So in this case, you see the score. The score is a number that goes from 0 to 1 that tells how many rows did match that exact rule. This is for the standard rules, but you can also provide your own. So imagine that you're searching your Lakehouse for any column that contains the word either confidential or restricted anywhere in all of your tables. So you can specify a regular expression that looks for this. So once you define the regular expression, like this is a case-insensitive search for words confidential or restricted anywhere in the string. You provide a few examples, and these examples serve as inline unit tests. So if the examples don't, so if the regular expression doesn't match the match examples and the non-match examples, then this won't compile, so you won't be able to run this. And then you can run a normal scan. And in this case, we are looking in any catalog, any database, in any table that has document in the name with sample size of 1,000, and for just this rule that we define here. So just one rule. And in this way, we can scan, even if you have like thousands of tables, this will give you an answer in a few minutes about what is the frequency of this word in there. OK, so we scan our content. Now we have classified our columns. As you can see, if we are looking at the email address here, we find several email addresses in different tables with in different columns. So now what we can do, we can say, instead of querying every table differently, we just run one single query. We say, let's look for all of the emails and get all of the data out of it. And this is useful for GDPR, right of access, like we said. So if we run this dx.search now with this search term with ernie@databricks.com, in all of the tables, so every column that has been classified so far will be mapped into this search query. And we're going to see an example of how this works in a demo. And the same for GDPR right of delete. So in this case, we have the same query. We specify that needs to be class email for these values. And we also added the yes, I'm sure false, which would, by default, print all of the delete comments here so that you see what is going to happen. So this can run GDPR right to be forgotten everywhere in your Lakehouse. So thing to remember is that once you do that, you also need to run a vacuum to make sure that the files are actually deleted. But yeah, at least you have the first step. And well, actually, the vacuum could be embedded to run the vacuum on all the tables. It would be also quite useful. A more advanced use case that we've seen a lot in cybersecurity is this one. So imagine that you have unstructured data that comes from logs. So this can come from very different collectors, and everyone has their own schema, and they collect data of IP, addresses, and other metrics, and they are ingested into the Lakehouse. So now, a common question that cybersecurity experts ask is, given a suspicious IP address or an IP address range, have I ever seen this IP address in my network before? And if yes, when and in which table. But there might be hundreds or even thousands of tables, and looking into all of them might be quite difficult. So DiscoverX can, in one command, once all of the IP addresses have been classified, create a reverse lookup table in which you can have the table, the column, the IP, the date in which that was detected, and the count, so group by and count how many times it was seen. In this way, you have a single table where you can answer this question. So how to do this? You would run a DiscoverX query to select the IPv4 and the ISO dates columns, so that would be classified by the scanner, and then group by table, column, IP, and ISO date, and then running a count over it, because what we return from DiscoverX is a data frame, so you can do any aggregation that you want out of it to collect data. And let's now take a look in practice how this works. David.
All right, so I want to give you a quick demo and show you how DiscoverX looks in action, and also kind of show you a few of the cases that Ernie introduced in action. So this is a simple Databricks notebook, and in order to make DiscoverX available in that notebook, we simply pip install. So it's available on Pipey as a Databricks Labs project, and that's why we have this DBL, so that stands for Databricks Labs. So we simply do a pip install, and that will now download DiscoverX from Pipey and install all the required dependencies as well. So that's going on here. Now this is done. So DiscoverX is available in the notebook environment. And the next step is then to import DiscoverX and instantiate the object here. And what we do here is we instantiate with the locale for the US, and that ensures that some of the built-in rules that we provide that are specific for the US are available here. So let's do that. And now we're set up, and DiscoverX welcomes you with a very short message here, how to get going. And now we're good to go. And if you remember from what Ernie presented already, DiscoverX basically allows you to map and query your Lakehouse with these two simple steps. So first we have to scan and classify in order to discover the content, and once that is done, we're able to perform these cross-table queries to work with use cases which are related to GDPR or cybersecurity or anything else. So let's go ahead with scan. So in this case, we scan any table within all the catalogs that start with sample data. So you see sample data star, so any catalog that starts with the word sample and data is included in the scan here, and then we would scan any table and or any schema and any table here. So let's kick this off, and now DiscoverX will present you once it started. It will present you basically what it's doing. So it will show you how many tables will be scanned, which are included in this scan scope. It will tell you which tables are currently being scanned. So now it started, and here you see, so we have one catalog, one schema, 23 tables. The sample size for each table is the default here, it's 10,000. And then it will scan everything. It scans concurrently. This was pretty quick. And then once it's done, it will show you the results. So as Ernie presented to you already, it will show you how many columns it was able to classify. Then some of the specifics here. So for example, it tells you that it found 5 email columns in all of the tables. And then more specifically, the details for each of the classified columns, like what was the class for this column, what was the score, or the frequency that we matched with respect to the regular expression rules. And that's the scan, basically. So now that we've performed the scan, we're able to go to the second step and perform the cross-table queries. So if we start with some search, so imagine you want to return any content or any record in your Lakehouse that contains the term ernie@databricks.com, which is an email address, obviously. So dx.search will automatically infer that ernie@databricks.com is an email address. Then it will look for all the columns that have been classified as email and then return the content. So let's run this. And now you see the results. So dx.search will return a data frame. That's why we have the display here. And then it shows you the table, catalog, schema, and table names together with the results. So each of the results here is one record, and then that tells us that in table accounts we have one record in the column email. So that's what you see here in the column email, and the value of that record is ernie@databricks.com, exactly what we were searching for. And you could imagine there might be several columns, right? So in this case, we only have one column. If there would be several columns in the same row having ernie@databricks.com, then they would all be listed as part of this type here, or within this complex type, structured type. And then in addition to that, we also provide the entire row content, which corresponds to that record as a string here, in case you might want to do any further transformations, including the entire row content. Okay, so that in this case, we search for a very specific term. Another thing you might want to do is return all the content that has been classified as IP addresses. For that, we provide a select by classes method. So you have, so you can then specify the classes that you're searching for. Again, we wanted to return any IP related content, so we say, okay, return any content that has been classified as IPv4 or IPv6. And then we can trigger this, and this will return all the content. So if you imagine thousands of tables, that might return quite a lot of content, right? So this can become quite a big data frame. But again, the structure is the same as for the search. We have the catalog, schema, and table names, and then we return any of the records here by row. So in this case, then IPv4, IPv6, and the associated column name for this table, and then the value. And then, well, you see there's several rows, of course, many rows for this table, so all of the rows would be returned here. And also here we provide the row content. So this is this will return a data frame, right? And the advantage of this is that you can do anything now that you want to do with that data frame, like further transformations. If you think back at the use case that Ernie presented, the cybersecurity use case, where you might want to, for example, count the occurrence of each distinct IP address by table and column, we can use this select by class to return all the content that has been classified as IPv4, and then we can group by catalog, schema, table name, column name, and the actual value, which is the IP address, and then we can simply count. So we run this, and then you see here now the resulting data frame. So you get the distinct count for each of the IP addresses for each of the columns. Okay, so the search methods basically allow you to identify and return the content that you're searching for. But then if you think about the GDPR-related use cases that Ernie was mentioning, you might not only want to identify those that content, you also want to delete it if that is required, right? And for that, we provide the delete by class method, which works in a similar way. So you provide the scope. In this case, we want to, the scope is basically all the classified tables and columns. And then we provide the class that is relevant here, and then the value that we want to delete from our lakehouse, basically. And then, as Ernie mentioned, we have, well, you can imagine delete is quite a consequential operation. So by default, this won't actually delete. It will only return the SQL statements that would be executed against your lakehouse. So you see which of the tables we would query here and delete the records from, but it's not actually executed. If we change this to true, then these queries will actually be executed. So now any record that contains ernie@databricks.com will be deleted, from all of the tables where it's relevant. And then DiscoverX will show you in the end, once the deletion is done, a summary of what it has done and how many rows have been affected, so how many rows have been deleted, and in which tables. Okay, so far we've been only working with the built-in rules that we provide, and currently that's 16 rules. We're working on extending that and even providing maybe in the future other type of rules. But already now, you can imagine like probably you have in your company specific patterns that might be interesting for you, which are not covered by our rules, right? You might have, I don't know, a specific format for your customer ID or anything like that you might want to search for. DiscoverX provides a way to add your own custom rules based on regular expressions. So display rules will, first of all, show you all the rules that we provide. So here you see the built-in rules, and then you see currently we don't have any custom rule defined. So if we want to define one, we can simply use import the regex rule here and define a custom rule. So again, this relates back to the use case that Ernie presented. You might want to, for example, search in your data lake for content that is related to data source classification, like content that refers to confidential or internal or restricted data. So we define the rule by providing a name, a description, and then the actual regular expression definition here. And then we have these inline unit tests, a match example, and a no match example. So we can define that, and then once that rule is defined, we can pass it into DiscoverX, the DiscoverX object, once we instantiate it. And let me do that, and then it will show you now you have one custom rule defined with a name. And then we can basically trigger the scan now, and that should also include this new table. So we're covering the same scan space now, so the same scope, we search for everything or scan everything within sample data catalog, so to say. But now we should identify an additional or classify an additional column here, which we will shortly see once the scan is done. And here we have the result, and there you see there's a new table coming up here that has been, where one of the columns has been classified as data source classification. All right, so until now we've basically we've been working with DiscoverX in an interactive way, right? We've been scanning and searching interactively in the notebook, but you can imagine like at an enterprise scale, you might want to scan your lake on a regular basis, maybe even on a quite high frequency basis. And you might want to then save your results and not just run them interactively all the time. So for that, we provide a save method, right? So imagine that you simply schedule a Databricks workflow that has a notebook that runs the scan, and then you can basically save the scan result into a delta table that you provide. So let's do that. So that will now run or save everything into a delta table. And then you can use that delta table later on for, I mean, there are many things you can do with it, right? So you could use it later on in an interactive session and load it. So we provide a load method here as well. So you just load the scan result, and then you're able to do the searches and the deletes interactively. But another thing you might do is you might have some downstream tasks also as jobs, right? You might have a dashboard that might look like this, right? So that shows you the state of your Lakehouse on a regular basis. So this one would show you for each of the tables and what classes you have been are present in your data lake. But you might also then, as a downstream task, compute a table that is related to the cybersecurity use case that we were mentioning, so that shows you which IP addresses we have and how many of those, and create a dashboard based on that. So all that is possible, yeah, that's basically what I wanted to show to you. Back to Ernie.
Thank you, David. right? So where can you get it? DiscoverX is part of the Databricks Labs project, so you can install it with py-dbl-discoverx. The code is on GitHub. It's open source. Please provide your feedback via GitHub issues. It requires Unity Catalog to work because we are using Unity Catalog metadata in order to get all the information from it. It's available through Databricks Labs, which means that it's not part of the SLAs of Databricks product. We provide best effort support though. And it only works with string types. As we just mentioned, the complex types are coming soon. The features coming soon are integration also with the upcoming Unity Catalog features. So as you can see, we will have some PII detection tools that will also tag the data. So this will eventually converge into the tags of Unity Catalog. And if you want to hear more about that, there is a talk in about 30 minutes about what's new in data science and machine learning, and there's more info about that. Scanning of complex types, this is coming soon. Column name rules. So imagine that you have several columns that have similar names. So customer ID, ID customer, or things like that. You just might want to have an overview of where they are and tag them directly. This is also coming soon. And AI-based rules. This will also have some zero-shot classification examples that are going to come soon. And that's it from us. So thank you very much for your attention. And any question?